All right, morning everyone. My name is Sievers. I'm here on behalf of the International Federation of Airline Pilots Associations. My background is that of I'm a retired 747 captain, but I have been on the ICAO Met panel since its beginning, 2015. So it's about ASH, where we focus on safety. Pilots Association has requirements. They are in the IFALPA Annex 3, and I bring a condensed version to you. I will be talking about the Road to QVA, and the introduction to the EASA paragraphs. And finally, I will ask the question if our requirements are fulfilled by what we have today. The requirements. Okay, we want 3D predictions of volcanic clouds, plus time, of course, continuous validation. I know that's not so possible over the oceans and remote areas, but we want validation. Aircraft sensors for the clouds and pilots to be trained on QVA and all other forms of volcanic ash. Then the ash, of course, needs to be shown in color on the EFB, on the electronic laptops, devices, whatever the pilots have in the cockpit. And we want a flight track in there in 3D. So it's appropriate to the phase of flight what is shown there. And same information content is as on the ground, so that there is one view of the ash that is available to all. And Rory talked about the dose, and well, we'd like to have a record of that on the flight plan or in the flight documentation that shows how much ash has already been seen by the airplane and how much is still available, and then see that the flight plan is well below the value that is allowable. And for good measure, this is maybe future stuff. How about hypothetical eruptions? Information about volcanoes that are in a restless stage need to be considered in flight planning. Information on SO2 clouds needs to come to the aviation system. Those of dissimilar redundancy and alerting. By that, we mean that the ash advisory centers, the graphics, it's all good and fine, but it takes a long time to come to the cockpit. But by that I mean that the ash clouds take maybe 15, 20 minutes to reach level 500 or higher. And so that's the scale against which we work. You need to have the information now, please, as soon as it's detected. And there's one way available, like from satellites, directly linked to the EFB. It sounds futuristic, but something like that can be done for convection clouds, and eruptions are some kind of convection. It's a collaboration work between what's coming out of the ground, thrown up, but then this hot air mass with stones inside or dust or whatever. And that's when convection takes over. That makes the thunderstorm clouds. So why not show it on the EFB that there is a very, very fast growing thunderstorm cloud? Doesn't matter. If it's a thunderstorm, we like to avoid it. If it's an ash thunderstorm, please avoid it too. Then we need a single website that shows all the ash. No use or help clicking here and there. Flight Radar 24 is actually quite good at that. That's showing all the ash for all centers. So now I bring you some real ash. 2015, I flew to Buenos Aires, and was I think the Calbuco eruption going on the other side of the continent in the Andes, and we had to work with ash, and I collected some, which you see on the left. That's my personal ash cloud on the right. It's resuspended ash, does have to shake a little jar, and then I have an ash cloud. And it's guaranteed to work. It has flight experience, 1,000 kilometers, not 1,000 hours, but it works. And I used to carry it around because the probability increases I will have a safe flight, because one ash cloud is not so probable, and two ash clouds at the same time. Rory, you know about probabilities. Two ash clouds at the same time is highly improbable. Good. Now what do we have here? Sahara dust. Rory mentioned dust. it can be everywhere. I've seen Deutsche Wetterdienst publish information about 2 milligrams per cubic meter or more of Sahara dust in Germany, or over Germany rather. It's a murky view of the world that you get. You see it here on the left side in my screen. And when you look at the engine, which I did here, you see that the engines also see ash, and they get brown at the edges of the fan and at the also slightly aft of that. So some dust goes into the engine, it accumulates, maybe it does abrasive stuff, maybe it even blocks some fine cooling pores somewhere in the engine. Sahara dust is not good for your engines. Oh, 2010, that was good. We had a blue sky over Europe. I was there, I had to use sunscreen. It was very nice. Yeah, some people looked at these charts and they were actually concerned and canceled flights. It was a lot of politics, a lot of cancellations. And so that's how we got to what you see here on the left. Eurocontrol published a chart or a set of charts or daily charts that showed where the ash was thickest. That's on the left. And they added a 60-mile buffer, and that kept everyone safe. And we could go flying again in Europe. Then the evolution continued. UK Met, they showed the same, so for the same day, same time here, this is what you see. They showed the high concentration, or what you see, predicted ash concentration that exceed acceptable engine manufacturer tolerance. So that's black. And you can get some more ash in red. That's already progress. And this is then a year later, essentially, where we are now. You have the European ash concentration charts. You can read all about them at EASA. We have the concentration levels low, up to 2 milligrams, medium up to 4 milligrams, and beyond. And the color scheme is accordingly. Operators have to do a safety risk assessment that gets approved, and then they can fly in whatever they write in their safety risk assessment. Let's say they get an assessment for low concentration ash, and let's see what it does. You see the two enlarged inserts here, and there is a thick blue line. That's the ash advisory that blocks flights from Europe over the UK and beyond. And if you do the ash concentration chart and use that one, you can see it's only low concentration, and flights from those operators that have the risk assessment can go through and operate. And this was a more recent example of ash concentration chart use during the La Palma eruption. Meteor France was so kind and do some ash concentration charts, and you see the effect on the left. If you operate according to the ash advisory, flights to Tenerife Island, that is this one here, are all blocked. That's a holiday destination with lots of flights. And on the right, you see the area is smaller, and only the southern part of the island is affected by ash, but it's low concentration. Bottom line is flights can continue to operate. Of course, the cost function that Raimund brought up is up to the operator. Does he even want to fly there? But that's what they have to decide. Now we come to another stage. Raimund already mentioned the Eunadix AV research project that was from 2016, 2019. From my perspective, as a non-researcher, it was a huge project. It brought together lots of research capability from Europe. And we had what is now called QVA. We had quantitative volcanic ash, just another version. Nowadays, QVA comes with 5,000 feet blocks of airspace. Well, we had that in Eunadix. We had 1 hour time steps between forecasts, and that's more than a final resolution than we will get at QVA. We had probabilistic QVA, probabilistic ash. because the ensemble was something like 160, 170 members, and you could select how many members of the ensemble of the forecast would go into the display. 75%, 50%, 99%. And well, I always ask my question, what if we only go to 75%, don't look at the 25% that are left, and the safety pilot wants to know why? And I can say, oh, I don't know. So we have to look at what the effect is of including lots of ensembles. I did that once, and on the left you see a 75% example, and the concentrations are clearly shown in color. And on the right, you see that the area covered is essentially the same, but there are some higher concentrations. So the flight inhibitions or impacts of ash are higher with the 99 percentile, but thanks to the 5,000 feet blocks and the 1 hour resolution, the overall area is much smaller than what we are used to now with the VAGs that can encircle half a continent with just a few points. So go for lots of percentiles. What we had here is another thing. Pilots like to see what's happening around them. We like to look out of the window. If that doesn't work for what we want to look at, we like to look at the EFP, at the electronic charts. So the Aeronautics project projected the charts onto an aviation background, and you could see the progress very nicely, which airspace is impacted at what point in time. Enhanced situational awareness, that's what I wrote on the slide. Okay, and for anyone actually who wants to know, a detailed scientific kind of project description is available at the link at the bottom of the slides. This is non-scientific. Well, no, it's not non-scientific, but I'd like to draw your attention to those who wanna to go to the QR code. It takes you to a short movie that is a description of the project. What I show on the big screen here is that we actually flew around or through the simulated QVA, the simulated Aeronautics ash, thanks to the calculations that Flight Keys did. It was possible, and it worked, no ash damage. It's all simulated. Now, after all the simulation, back to the real world. Regulators, EASA and states. Are there any regulators in the room? Could you raise your hand, please? 1, 2, 3, 4, 5 regulators. Okay, could you please, I appeal to you, go to your colleagues and tell them there is a new thing, ash, it's coming. It is called QVA. Get onto it. Please tell your colleagues. Yeah, because the flying doesn't happen because Rory and his colleagues put out some graphics, or the airlines are happy with it. It all has underpinnings. There are rules, EASA rules. They tell us, or they tell aviation what they have to write in their risk assessments. They have suggestions, good suggestions, like if the airplane has ash detectors, volcanic gas sensors installed. It's not fantasy from the Pilots Association, it's EASA text. And contaminated airdrome ops needs to be considered, like the braking info, braking performance, pre-flight precautions, like MEL deviations. MEL, that is the minimum equipment list. You may think that everything works when you step into an airplane. That is, of course, an illusion. Airplane has millions of parts or hundreds of thousands of parts, and some of them are there in 3 or 4 times, and the engineers, they have come up with ways to figure out how many you really need. Do you need 4 of one kind, or maybe are 3 enough, and then one can be out of service for a certain number of time, like 3 flights or 4 flights until maintenance can take over. So for volcanic ash operations, the list of parts that are allowed to be out of service goes down. You have to have a really good airplane that's working. That has to be considered. And here is more hands-on. That was from 2011 or 2013. Also to be considered in the safety risk assessment, the things that come to mind when you think of volcanic ash. Normally, like the engines from Rolls-Royce, the windscreen can be quite opaque. And we have fuel contamination, could also be a factor, and air conditioning, anything. And all of this is what the airline has to write down in a safety risk assessment. And while I have been into ash for quite a long time, I must say that I haven't seen a real good safety risk assessment, right? Because I haven't seen any full safety risk assessment. They must be thick and proved, and I don't know them. So let's see where we are with QVA. QVA is not identical to what we had in Eunadics, but Eunadics is, in my view, a very good precursor that demonstrates a lot of QVA. So with QVA, we get, yes, predictions improved. Good. Even the probabilistic ones. Validation of QVA, I haven't heard much about it. Probably like the same kind of validation that we do now with the mass, that the satellite sensors over a certain place or something like that. But there could be more. You could use the LiDAR network. You could use the ceilometer network of Europe to peek into the clouds from below. And oh yes, there are also networks of these sensors available all over the world, like the US. Yeah, and pilots need training. The ash info has to be clearly shown, flight track, and the additional requirements I mentioned already. Bottom line, I told about the requirements, the road to QVA, the introduction to the paragraphs, and the question now is, are the requirements fulfilled already? I would say partially. We need to work on pilots' education. Nobody knows about QVA. I mean, it's years back and away, and the pilots need to know what's happening now. The regulatory environment, 5 regulators in this room. I'd submit that's a low number for an event like this. And I haven't seen any text from regulators. We just have to make sure the presentation of QVA to pilots is done properly, and yeah, verification. And with that, I'd like to close my talk. Thank you.